Hello and welcome to Maths with Mr Amison. In this video you're going to get to practice how to find the area of sectors and the length of arcs. If you need to recap this topic then please watch Mr Chowdhury's video. I'm going to start by showing you an example, talking through it, and then giving you time to copy it down and have a go at one yourself. Feel free to pause at any time. So in this question, the first thing I did was recognise that sectors are fractions of circles. A circle in this case that would have had a radius of 4. So this sector, the fraction of the circle is based on the angle that would have been at the centre of the circle. So this angle here would have been at the centre of this circle. So if we have an angle of 45 degrees here, that's 45 out of what would have been 360 degrees. That tells us that the fraction of our circle is 45 over 360. So the area of this sector will be that fraction, 45 360ths, of the area of the circle. So in this case the area is equal to 45 over 360 multiplied by, because of we can replace in maths with multiplied by, of the area of the circle. The area of this circle would have been pi times the radius squared. Now the radius would have been 4, so pi times 4 squared. So the area in this case, if you simplify this by either calculating it or typing it onto the calculator, you get an area of 2 pi centimetres squared, which is a valid answer, but if it asks you for a certain number of significant figures or decimal places, then we can do that by typing it into the calculator. So we get 6.28 centimetres squared. The arc length, it's useful to know that the arc is the curved part of this shape. An arc length is part of the circumference of a circle. So the arc length here does not include the 4 centimetre radius here or here. So the arc length here is the same fraction of, not the area of the circle this time, but the circumference of the circle. So the arc length here is 45 over 360, 45 360ths of the circumference. Now the circumference is pi multiplied by the diameter. The radius of this sector was 4 centimetres, therefore the diameter, which would be from one side of the circle to the other side of the circle, not to the centre of the circle, would be double that radius, so it would be 8. So the arc length is 45 360ths multiplied by the circumference, which would be pi times 8, because it's pi times the diameter. The arc length, therefore, if you simplify this or put it into a calculator, is just pi. So the arc length in this case is 3.14 centimetres, so 3 significant figures. Take time to copy that down, make sure you understand it, and then have a go at the question on the right hand side. So in this case we have a fraction of 135 360ths, because that's the angle at the centre. Our radius is still 4. So the area of this sector is 135 360ths of the area of the circle. So the area is that fraction of pi times 4 squared, which simplifies to 6 pi, or 18.8 centimetres squared, to 3 significant figures. The arc length is 135 360ths of the circumference, which is that fraction of pi d, or pi times 8 in this case, which gets us 3 pi, which is 9.42 centimetres. So here are 6 questions for you to try. See if you can have a go at these ones Some of them do get really quite tricky towards the end. So here are the answers to those 6 questions. For question 1 and 2 we have exactly the same shape. 1 we're finding the area, 2 we're finding the arc length. Here we have 30 degrees, so the fraction of the circle is 30/360ths. The radius is 4, so we have for the area 30/360ths multiplied by pi times the radius squared, or pi times 4 squared. That simplifies to 4 pi over 3, which is 4.19 centimeters squared. For question 2, we have an angle of 30 degrees again, so 30/360ths. Our diameter is 8, so the arc length is 30/360ths multiplied by pi times 8 pi d, which is 2 pi over 3, which is 2.09 centimeters squared. For question 3, the angle at the centre changes to 50 degrees, so the area becomes 50/360ths multiplied by pi r squared, so pi times 4 squared, which is 6.98 centimeters squared. The arc length is 50/360ths multiplied by pi d, so multiplied by pi times 8, which is 3.49 centimeters. Question 4, the area and arc length of this sector. This time we've doubled the radius to get this to 8 centimeters, so 50/360ths multiplied by pi times 8 squared, which ends up being 27.9 centimeters squared to 3 significant figures. The arc length is 50/360ths of pi times the diameter, so pi times 16, which is 6.98 centimeters to 3 significant figures. Question 5 is a bit trickier. This time we're given that the area is n pi and that the radius is n. So 30/360ths, because that's the fraction, multiplied by pi r squared, pi times n squared. So the area, if we simplify this, 30/360ths is 1/12, so it's 1/12 of pi times n squared. So it's 1/12 of n squared pi, so n squared over 12 pi. Now, we're also told that the area is n pi. So n squared over 12 pi should equal n pi. I can divide both sides of this equation by pi to get n squared over 12 is equal to n. I can then multiply both sides by 12 to get n squared equals 12n, and then divide by n to get n equals 12. Question 6, the area of this sector is n squared pi. We have to find the value of n. So if the area is n squared pi and the angle at the centre is n and the radius is n, we have n/360ths of the circle multiplied by pi times n squared, because n is the radius, which gives us n cubed over 360 pi. Now that should equal n squared pi. For a similar reason to this one, the n cubed over 360 should be equal to n squared. So n cubed equals 360n squared. Divide both sides by n squared, so n is equal to 360. Alright, well thanks for watching. I hope you found this useful. Speak to you soon.